elements here. Okay, so this afternoon, we're going to be pursuing a set of hands-on explorations. And these explorations will progressively bring you through a series of mechanisms in agent-based modeling more generally, but also within AnyLogic in particular. And specifically, we're going to be introducing elements that are reflective of several key components of agent-based models that we mentioned this morning. The presence of agents with attributes or parameters, these fixed characteristics, either continuous or discrete in character. The presence of populations holding those agents, and composed of by those agents, and introducing heterogeneity across these agents in a way that has strong bearing on our ability to address issues of health disparities and equities, issues having to do with gaps in health status and with sort of ecosystems of parties of different character. We're also in this first exercise going to be exploring a little bit AnyLogic's capacity for visualizing components of these models in a fairly declarative way. And by that, what I mean is a way that specify what we want to depict, and AnyLogic takes care of arranging that rather than having to specify all the details of how. And finally, we'll be going into some characterization, again, declaratively, of statistics on a model, characterizing some of the model attributes through summary statistics. So all of that will be in this first exercise. And while we pursue that, I'll be introducing the AnyLogic interface and the AnyLogic modeling vocabulary. Okay. So that's the plan for the next hour or so. Okay. Okay, so in order to do this, I'll need to ask you to get your AnyLogics fired up. You should be familiar with how to do that. And I just want to remind you that if you get to that first initial screen, that first initial screen, and you're seeing something like this, you'll want to minimize that. And I'm going to close previous projects so we don't get the elements of the different projects confused. I did that by doing File, Close All. Okay, so I'll give you a moment to get your AnyLogics up in that sort of way, and then we'll get going here. Okay. Okay, so we're going to go through a guided exercise here that will shed light on all of these components we've just discussed. And first, we're going to build a new model. Okay, in order to do that, use the File menu, do New, and you'll say New Model. Okay, and I'm going to call this simple gender disparities. Okay, and it points to a troubling disparity across different genders in terms of income. The model time units are actually not going to be so relevant, but I want to highlight the fact that when you create a model, you're choosing the time units, and I use that word advisedly. You're choosing the yardstick by which you measure time. It's not that by choosing seconds, the model's going to go a lot slower, that it's going to go 1 second at a time, whereas if you chose years, it'll go 1 year at a time. No. it's just the time, the reference time unit that it uses for what does one time unit mean? Does it mean 1 year, 1 second, 1 millisecond? Any logic will actually go as fine-grained as you need it to simulate the processes, okay? So you're not choosing the time step, but the time unit here. And even though we won't require it, I'm gonna set the time unit to days. Okay, it's always worth being careful there. I will say that people can get in trouble with that if they forget to change it initially. And they accept defaults for things like the frequency of charts updating. And so if they set it initially as seconds, and then they add a chart and they leave it as updating every second, and then they say, oh, later I want to have the model in time units of days, let's say. And maybe you're simulating things over many days. Often you choose units which are kind of suited to your needs and where things of interest play out over whatever time unit. You may have this chart updating every second. It may be incredibly slow. And it's not for any deep reason. It's because you originally said, I want to use seconds as the unit of the model, and then chose the default to update charts every whatever the default time unit. Okay. So it's worth being careful. You notice you can also specify where this model should live. By default, it puts it in a models folder. Okay. I'm going to say finish here. You notice I didn't go and add any wizards to sort of add nifty features. I think, particularly for this boot camp, it's worth emphasizing the basics. And I want to give you a sense of how to put things together yourself, even if there are some nifty bells and whistles that will do some of the assembly for you. Okay. So you notice when it created that, it put me in a palette mode. Any logic interface, any logic graphical user interface, it's so-called GUI, has many components. We saw some of them this morning. We saw that over here in the projects window, and you can kind of click, you notice there may be these tabs here, you can click on this tab. This shows you a project's components in a hierarchical fashion. So there's a thing called main, and that's kind of the global environment, the stage in which the agents strut. It's the kind of the overall depiction of the depiction of the overall situation. And then there's some experiments here. There's some databases and so on we'll talk about later. But you notice that this depicts the model kind of hierarchically. And then there's a thing which is called the canvas, which is over here where we draw things and we sketch out pieces of the model. It describes what's in the model, okay? And commonly there's then a properties window, which depending on what's selected, either in the canvas or in this window over here, it will show you the properties of that thing. It will show you its characteristics, okay? So right now, this simulation, this experiment is selected. Notice we mark a simulation with an X, it stands for experiment. But you notice its characteristics are listed here. If we clicked on main's characteristics are listed here in properties, okay? And you notice that these are with these kind of, I don't know what they're called, expando or accordion windows or whatever, where sometimes this little right-facing triangle indicates you can sort of expand it or contract it like that. Okay, just be aware there may be things under these that you're not at which you're not looking at. Okay, so there's a set of additional windows. We'll be exploring them up here, and you can enable and disable which windows are shown using this menu. Okay, so for example, I could show a problems window, and that will often appear when I have problems with my model. It'll show me complaints about the model, or I can include a GIS search results. If a window disappears in you, like your property disappears, you can go back to view and get it back again. Okay, so properties show the properties of whatever selected in each of the canvas or over in this project. Okay, great. So we've added a model. This model doesn't have a lot going on right now. We don't even have an agent. We don't have a theory of personhood. Let's add a theory of personhood. Let's add an agent class. A class is talking about sort of a theory of this. It's a depiction of what it means to be a person in this case. Okay, and it summarizes personhood. So I'm going to right click in order to add this. I'm going to right click on the model as a whole, and I want the TAs to be on call on this. They should be on the lookout. So we should do new, and then we do agent type. Okay. Here we go. And we should add in a person agent, a capital P person. Okay. Capital P person. Okay. And you notice it says created from scratch. I'm not going to again do any of these bells and whistles. And you notice I could also add nice pictures. We'll be getting to the pictures, but for now we'll just say finish. Okay. So we've added a person class. Again, it depicts personhood, personness, what it means to be a person with respect to this model. Remember, all models from this morning are simplifications, like maps. They leave out more than they include. And what they include is a particular sort for your interest. Personhood here will be associated with characteristics of a particular sort for our needs. Okay. Okay. So let's go double click on person, and we see, you know, it's fine. Okay. So what we're going to do here is we're going to go and give this agent type, this class of agents, personhood. We're going to give them a face upon the world. We're going to give it an appearance. Okay. And for that, I'm going to go to the palette. You know, some people here get rather creative. And if those of you with more fertile imaginations could go down to the this pictures area. And it's been known that some people pursue this exercise I'm about to lead on gender disparities with fighter jets and other things. But I'm going to rein in my exuberance, and I'm going to go back to this place here. Notice I'm choosing between different palettes. Any logic palette window will show the current palette, okay? These are showing different palettes out of which I can draw the paint, out of which I'll paint this model. So I'm going to choose the presentation palette. And the presentation palette gives me a choice of some nice little geometric objects. I'm gonna choose this oval. There we go. I'm gonna stick it up there, and I'm gonna use that oval for the sake of this exercise. There it is. But I'm gonna make it smaller. I don't want it to be overwhelming. How did I do that? I clicked on it, boom, and I kind of shrunk it. There we go. And now I'm going to situate it. What am I doing? I'm using the arrow keys to move it around. I could also use the mouse with some alacrity to kind of move it around, but I kind of like the arrow keys because they allow me to kind of probe its location without much fuss. Okay. So how did I do that? Notice I dragged the oval into person. I took it from the palette and I clicked on it and I dragged, is what I did. That's what it is. I dragged it down here, and having dragged it, I could pull it like this and shrink it down, etc. Okay. That's what I did. Okay. Okay, ladies and gentlemen, this is what we're doing. Great. Okay, so next, having done that, we're actually in good shape to take the next step. Okay, I've introduced the theory of personhood, and the theory of personhood involves just a person as a geometric shape, a circle, in fact. Okay, that's all it involves right now. But that will be the ground in which we're built. Let's go add a population of people. We've added a theory of personhood, but if we run this model, there's no people in it. We have a theory of personhood, but no people to enact that theory. Let's go add some people. So how do we do that? Well, this population of people will live in Maine. It'll live in the global environment. It'll live at the overall level. So while we added this oval into person, it's in Maine that we want to add the population. Okay. Okay. So we're going to go to Maine now. And we're going to go back to the projects window. Okay. And in the projects window, I want to drag person into Maine. So again, I want to highlight the fact that I have Maine open as the canvas here. I am, with that selected, I am clicking on person and I'm dragging it over to Maine. Okay. So TAs, please watch. This is like key times where people may need help. So please keep an eye out for people needing help. Okay. Okay, so we just dragged that over. We dragged it from person over here onto Maine. Now, there's another step that I'm going to undertake now. This is an important step. Okay. I am going to click on population of agents here. So with that selected in Maine, with what I dragged in there selected, I'm going to change it from a single agent to a population of agents. Okay. There we go. Population of agents. Okay. And right now we're going to have 100 agents. That's the default. Notice it actually changed the icon. It changed it from something that was just says person, just something with a little open and closed bracket. It's 100 people. Okay, so that's what this is saying. It's 100 people. That is 100 persons in our population. Let's go run this thing if we could. Okay. By the way, am I screen sharing here? Yeah. I am. Okay, because I don't see an indication of it, but I trust that that's okay. Okay, cool, great. Guess it was hidden behind that. I'm gonna get the chat over there. Okay. Okay. Danica, if I addressed your question there about showing that last step again. In other words, I changed it from single agent. I changed it to population of agents. Are you okay? Danica? Got it. Okay. Okay. Yeah, we need more TAs here. Could someone write to some of the other TAs and ask them to get over here? There should be at least 6 at any one time for my specification. I just don't see the others. Sorry, they should be here in person. Yeah. Yeah, I want 6 here in person. Yeah. Wait, so no, beyond medicine TA. No, he hasn't used any logic before. So no.
Okay, I know that.
Yeah.
Marby and Sheila can't make it.
Okay, well, you can handle it. Just okay. So, ladies and gentlemen, let's go. So we just added this population. Let's right-click on simulation and let's run this. Okay. So how did I do that? Simulation is a built-in experiment. It was created for us. I right-clicked on it and I chose run, just like we did this morning. Okay. And you'll notice that here, up in the upper left, there's a population and it's listed as being 100 agents, okay? There you go. And if I click here to the right, and you actually were to drag down, so how did I do that? I click this thing here to open up this window, and I drag down this. I could go down and I could see each person in the population, and I could scroll through them, but they are singularly undistinguished, indistinguished population members, right? Here we have a population of people, 100 people, but they are kind of all just like each other. They all share the same thing, same face, okay? So we're going to add some characteristics. We're going to add some heterogeneity to these people. Right now, they all look the same. Not so interesting. Although I would note that in an aggregate model, all those people within a stock, in a compartment, in a state variable, whatever terminology you like to use in your corner of compartmental modeling, all of those people in that stock are kind of also interchangeable in the same sort of way. But one of agent-based models' greatest features is the ability to represent heterogeneity with ease. So let's add an age to every person, shall we? Let's go add an age. Okay, so I want you to open up person, okay? And in person, we're going to add a characteristic to them. We're going to add an agent parameter. It's going to be an attribute of them. It's going to denote their age. Now notice here that you might with understandably be a little bit confused, with good reason, because you may remember me saying, for example, in lists of characteristics, that age is often a state. It's something that's changing over time. But here I'm suggesting treating it as a parameter. Well, again, different models have different scopes. Something that in one model is treated as constant might in another model be treated as something that's evolving, depending on your time frame, for example. Maybe you're dealing with a flu outbreak of a span of just 2 or 3 weeks. It doesn't make sense to go into all details showing people's aging, et cetera, because those are not the dominant features of the situation that drive your factors of interest. You want to capture heterogeneity of age. You want to capture the fact that there's elderly people in the population as well as younger, but you don't need to capture aging as a evolving process, as a state. So we might treat it here as parameter. By contrast, if we were wanting to represent, the varicella zoster causing chickenpox, or over the life course, or we want to represent TB over the life course, or if we want to represent diabetes, you'd want age as a changing attribute. So the model scope will vary depending on your needs. Here, we're going to be treating age as a parameter, okay? So let's go add age in. Now, who has age here? Is it Maine who has age or what? It's person. It's part of our theory of personhood that a person has an age. So let's go to person and let's go drag in a parameter. How do we do that? Well, let's go to the palette and go to the agent element of the palette and drag in a parameter. Okay, there we go. And this will be called age. Okay. Called age. And it's a double parameter. Okay. A double means a double precision value, but essentially we use it to model a continuous parameter, something that varies continuously. It could be 39.3, it could be 29.4. We could make it an integer, that would be another option. I'm just going to leave it as a double. Okay, And you'll notice there's a default value. That's the value if we don't, and mark my words, the default value for a parameter is the value that is assumed. If we don't specify a value for it, that's what it will assume. Not the starting value. Parameter typically don't change. But this is the value if we don't specify anything for it. We might fill it in, but generally here we're going to specify something for it. Okay. So it's going to be an age there, and it will have the default value of, let's say, 0. Okay. It's not particularly privileged. Okay. Great. So we've given each person the ability to have an age. It's part of our theory of agenthood that they have an age. Great. Now let's set up what the age assumptions are. Now, to do that, you should know that a parameter is important. As far as it's kind of an any logic thing. But a parameter in any logic serves two functions. It characterizes an assumption. That's the first of those. But secondly, it communicates that assumption from the point of creation of the agent to the agent itself. Okay, so where's the point of creation of this agent? What is it that holds this agent? What is it that holds agents in this population? Anyone want to venture a guess? What is it that holds agents in this population? It is it's in main, and begins with P. It has a P and an O. Population, thank you. So let's go to main. Let's go down main. And we'll go to person. And you'll notice the person is the population. So we should really call it population. It shouldn't be called person. What am I doing calling it person? That's terribly misleading. It should be called population. That's what that should be called. It's the population of agents. And indeed, it says it's a population of agents. See that right there. So its name should reflect its function. Okay. So where we're going to specify the assumption for this is right here, where it says age equals. Okay. We're going to draw the age from a distribution. And I'm going to draw it from a particularly simple distribution. I'm going to draw it from a distribution, uniform distribution. This is one of any logic's many distributions between 0, 0.0 is a double precision value, and 85 years old. Okay, no sense of humans here. Okay, so what we're saying is for each person in the population, this is the rule to determine their age. Okay, that's what that says. So for their age, this is how to get their age. This is how you go and find out their age. You draw it from the uniform. For anyone wondering whence that comes, and I'm seeing people in the back having trouble seeing here. So what I'm going to try to do is drag up my notepad here. Here we go. And here we go. I'm going to, hey, come on. Let me see if I can make this zoom. Control plus. Okay. There we go. How's that? Okay. Okay. Good. So that is that is where once we get the age. Okay. Great. That's where age is, from which age is drawn. Great. So let's go run this model. My colleague Jeff McDonald counsels that with a model, you always want to keep it within 30 minutes of being runnable. This is based on decades of running modeling projects and being asked suddenly, oh, could you demo this model? Could you show it to the stakeholder? Is there any way you could give a presentation on it tomorrow? He argues you always want your model 30 minutes from being runnable. And I like to run a model on an ongoing basis. As I change it, I run it. And if I notice odd behaviors, I have a good understanding of what step I last did before that, so I could figure out where that behavior is coming from. Maybe it's a bug. And I've only changed one or two things, so I can find it easily. Maybe instead, it's an emergent pattern, and I know what one or two things I did that gave rise, that catalyzed that pattern, or that made it visible. And that's often good for insight, for learning. So you want to keep your model runnable. It may not be ready for prime distribution, but you want to keep it runnable and keep on using it, keep on learning from it. This is part of agile modeling. Just keep on engaging with it. Okay, so let's run this model. Shall we? Let's run it. So I'm going to right click on simulation. I'm going to say run. And here we go. Okay, so there we go. We have a population of persons. It doesn't look any different. Okay, but let's go click here, and I'm going to drag down, and you see, oh look, here's a 61-year-old person. Here's a 34-year-old person. Here's a 17-year-old person, 28, 82. I'm going through each person in the population. I've given them each an age. Okay. I've given each person an age. So I now have age as part of my theory of personhood, and I have a population with varying ages. I've introduced heterogeneity. Okay. Heterogeneity again. Someone who's not planning to pursue any logic may think this is all very any-logic specific, but no. Heterogeneity is one of the defining features of agent-based model. Features in the sense of characteristics, but also advantages. And the fact that we could add it in so ready a fashion is a testimonial to, the ease of doing this. Okay, so I'd like to do something more though. I'd like to place them visually in a location that's given by their age. Okay, so let's go back to Maine. Okay, now this is a little bit any-logic specific, to be sure, but if we go click on Maine, and in order to do this, I'm going to click on Maine over here, okay, in the projects area. Make sure your properties show Maine here, okay, that it's showing Maine. Make sure you've gone down Maine, okay. And in the space and network area here, you will see this is characteristic called space and network, okay. So within Maine, you can specify how to lay things out for populations in Maine, okay? And in particular, you can say characteristics of how they should be laid out in space. Now, we're going to take advantage of that, but at the moment, we'll do something even simpler. So in general, we'll come back to this issue of laying things out according to rules specified declaratively. But for now, clicking on the population itself, we're going to set the initial location. You see that? Okay. And what I'm going to do is do the following. I am going to go and say at the specified point. So I'm going to place the agent at the specified point, and I'm going to give its X location the agent's age. Okay. Now, I wish I could just say age, but it actually is not going to let me. It needs some more cues. Whose age it's going to say. Okay. If I said age here, I think it would complain in a most bitter way. I could be wrong, but yes, it says, I don't know whose age you're talking about. And what I need to actually say is self.age. It's the age of the person that's being created here. Okay, this is a kind of specific thing for this area. It's when the agent is created. Okay. So it's self-age. It's the age of this agent. That's what it's saying. So let's run this thing. Shall we not? So what did I do? If anyone's falling behind, I'll just rehearse again. I clicked on population. I went to initial location. I said, place the agent in the specified point. I had to sort of expand this thing. Place it in the specified point, and I said, make its X location given by self age, make its Y location. Well, I haven't specified. They're all going to be at 0, Y, which is kind of unsatisfying. Maybe I'll put it at a uniform. Uniform, we know how to draw from a uniform distribution. We did it up there. Maybe I'll do it between 0 and 200, something like that. Okay. So I'm gonna determine its X location will be by age, its Y location will be random. You could also have it depend on the agent's identity. Okay, I'm going to do something different. I'm going to go up to here. There's this little thing called build the model. See that? Build. Now, this concept of build, it's some jargon that comes from my com. It comes from computer science, okay, and from software development. It basically means prepare the model to be run and check it. Make it ready to be run. And that involves checking whether it makes sense, whether any logic understands it, whether it understands what you're trying to say. And have you phrased it in the right way? And you notice it said build completed successfully. Here's one piece of sage advice, ladies and gentlemen. If you're doing this sort of modeling, I don't care if it's in any logic or other type, build early, build on. If you're doing it in recap, build early, build on. If you're doing it in Julia, build early, build on. Run early, run on. Okay. So mark my words there. I'm going to right click on simulation. And there we see agents. So if I were to ask you, what distinguishes this one here that's furthest to the right? Why is it furthest to the right? Because it's the oldest individual in the population. The ones over here are the younger ones, right? Okay, great. So we've just seen some aspects of laying them out. That was an aspect of heterogeneity. The y-axis was just random, nothing deep. Okay, ladies and gentlemen, now we're going to do something a little bit more involved. I'm going to introduce a characteristic that's categorical in terms. Okay, and I could do so dichotomously or not. I could do so trichotomously, or something more. I don't feel strongly about this, but I'm going to add in to this model. I'm going to say new option list, and I'm going to add in something called sex. Okay, and this will be someone's biological sex, and I'm going to, I think, for the sake of the scope of this model, I was planning to do male and female there to represent male and female disparities in income, and often in being paid, but I could add other just as easily. I'm going to put male and female. The only thing is the logic will be a lot easier if I say male and female. So I hope it's okay for biological sex if I just use those for now. Okay, and you could always add more later. The logic will be a little bit different. To start us out, I'm going to say male and female. How did I do this? What did I do? Let's go rehearse that again. I right clicked on this. I said new option list, and this gives me a choice, allows me to specify a categorical collection of possibilities. I'm going to say sex, capital X. Java, and by extension, any logic. This Java language in which any logic is built is case sensitive. It cares whether it's a lowercase or an uppercase. So you want to be careful about your case. Okay. This is an unfortunate fact, but I'm going to say male, and Let's do female first. Maybe I'll do female first. It doesn't matter. It's just a collection of possibilities. But there we go. Let's say female, male. It could have been male, female. The point is, it's two alternative values for it. And I'm going to say finish. So we've just defined kind of the possible values for someone's sex. Okay. We could have done the same for provinces of Canada. Manitoba, Saskatchewan, British Columbia, etc. listed. We could have done so for someone's country of birth, but we've done so for sex. Now, why have we done that? Well, it will allow us to be a little bit more clear when we write out things in the model, because we can actually refer to males and females instead of 1 and 0. 1 and 0 is hazardous. For those of us who build software for a living, or those of us who depend on transparent models, if your models are full of 1s and 0s, it's easy for the modeler to get confused. Remember, is it 1 for male and 2 for female, or is it 0 and 1? If a stakeholder looks at it and sees a reference, does this equal to 0? They don't know which one is meant. It's just easier for you to refer to male and female. So in general, I encourage creating these option lists. Okay, so let's go take a look at this. And now we have sex defined as a kind of a category. Let's go give persons, each person a sex. How would we do that? How would we give person a sex? How would we add sex to our theory of personhood? Anyone? Yeah. That is exactly right. So it has to go into person because it's a characteristic of a person. It's part of the theory of personhood. So person encapsulates the theory of personhood. Okay. So we're going to go to person. We'll go to palette. We'll drag in parameter here. And this will be sex. Okay. Now notice I made that lowercase. And this is by convention. Generally, we make parameters lowercase things. And the point is, this is going to hold for a given person a particular value from the possible sex categories here, male and female. Okay. So what did I do? What did I do? I opened person, I went to palette, and I dragged in a parameter to palette, and I called it sex. Okay. There we go. Okay. There we go. It's sex. Great. We're going to assign this to a sex. Okay. In other words, it'll be type sex. In other words, this value, whatever a person has for their sex, it'll be drawn from this category, capital SEX. That was the thing we just defined with male and female. This is going to be a particular value drawn from that category. Okay. Maybe its default value will be female. We don't specify it, but we're going to specify it. We're going to specify it here. Going to specify it. Okay. Great. So this is what we're doing. Now we specify default value. Now, where are we going to specify? How are we going to assign different sexes to each person in the population? Where do we do that in the model? We saw it earlier for age. Where do we do it? We do it in main. And where in main? Population is right. It's the population that specifies the characteristics of it. So if you had two cities, each of them might have different characteristics for age. You'd have a different age distribution for each. So you draw for each of those from a different age distribution. So it's in each population that we specify kind of the rules for assigning values. So right now this says female. Now, I'm going to actually specify a separate rule here. Okay. what we're going to do is do the following. Now, there's a couple ways we can do this. We can. I'm going to show you one way, and later we'll have another. Okay. I'm going to say sex is a randomly drawn sex with equal probability from the two values. That's what I'm going to do. Later, we'll see how we can have a distribution, like we can actually draw out the distribution. I'm going to say this is random from, okay? It's going to be a randomly drawn value from sex, okay? But you actually want to say sex dot values. I'm going to put this up on the big screen so those at the back can see it. They're not woefully disadvantaged. It looks like that. Okay. Now, I need to explain the syntax. We actually saw something kind of similar before with this uniform. So these things where I have parentheses, it's calling a function. Okay. So I think most of you will have seen this in R before. You say like plot this data, or you say a histogram of this data. But, you know, virtually everyone will at some point in your high school time, you might have seen, you know, sine of 90 degrees or something like that. When you take something like that, this is the function name and you're applying it to this. This is the value it needs to do its job. This is called an argument. And I will oversimplify the situation by saying it's what's being specified is a parameter. Now, this is a little bit confusing, but it's being used specifically in the function context. This we're calling a function random from, and what does it need to do its value? Sine needs an angle. What does this need to do its value? It needs a bunch of possible values, and those are taken from sex. And this is a call that just means it doesn't need anything to do its job. It has everything it needs to do its job. You don't need to pass it anything. Not an angle, not a bunch of values. You just say, give me all the values and you are put in this category. And it's going to give you female male. And then it's going to draw a random value. Yes. No, no, because this is great question. Java is case sensitive, so it's going to care whether it's this or this. And the reason that it matters actually is that sex is defining the category. It's the set of possible values you can have, male and female. Whereas actually here, it doesn't even know of something called lowercase sex. That's down in person, and that would be the particular value this person has. So this needs it to give it all possible values from this category. Okay, it's asking, tell me all your possible values. And it says male, female. This has been provinces dot values. Then it would have given you the names of all the provinces, all of them, all 10 of them. And then if it had been the names of your country birds, it would give you 250 or whatever possible name. So this is saying like, hey, category, give me all your values. And then it's calling random from. Okay. Hopefully that's helpful. Any other questions related to this? Okay, so let's go run this thing. Remember, never have a model that's more than half an hour for running. So I'm going to right click on this and I'm going to run it. There we go. Okay, now you can't see any visual difference, and we'll remedy that in a minute, but we can always click over here and we can drill down, and then we'll see, okay, here's a female, 62 years old. A female is the default, and so we want to make sure oh, there's a male is 28. There's a male is 81. There's a female 79. There's a male is 24. They're like within seconds of their birthday. Take a look at that. Okay, their 25th birthday. Here's a male is like 65, going on 65.5. Okay. So we just given people a sex, and we've drawn it from those possible values. Who needs help? Who needs TA help? TA help is in the offing. We can form the phalanx if we need to, and defeat even the worst of problems. So who needs TA help? Okay, okay, so let's keep on going. Let's suppose we want to color these folks by their sex. Okay, let's go try that. Okay, I want to color them by sex. Maybe I'll make women yellow and men gray. So let's go try this. Okay. So I am going to go into. I want to make. Okay, so let me say that again. I want to make women yellow and men gray. Without privileging any particular colors. Where would I do that? I suppose I wanted their appearance. The appearance of women to be one way and men the other way. Where would I do that? Where would I do that in the model? Okay, in Maine? Anyone? Maine? Okay, so help me think through why Maine? Why would it be in Maine? It's a good idea. I mean, Maine has a lot of stuff in it. It's a population in it. But actually, this is part of our theory of personhood. Remember at the beginning, the first thing we did with person was to add a circle in for them. You remember that? That was part of their appearance. And this is part of their appearance. I bet it's in person. And it turns out it's in person. Let's go to person. Let's go to person. Okay. I'm going to go to person, and there be our circle. By the way, if you look in Maine, might confuse you a little bit. There's a circle there. Oh, don't be that just shows where the agents. That sort of shows the home base of this population of agents. Don't worry. Don't worry about what that means. When we added this in, it creates a depiction of one of the agents to sort of show where they get placed visually. At least that's what it used to do. And Wade could probably, in a sage voice, tell me if that's still the case, because I did some experiment and made me wonder. Anyway, here's person, and part of the theory of personhood is their appearance, and this is part of their appearance. Right now, all it is a circle. All it is one stinking circle. So I'm going to give them a color. Let's add a little bit of something more. So when I click on this, where do you think I go? Here are the properties. Where would I go here? Appearance is right. Boom. There we go. The appearance. And you'll notice that, and this is something that's about the anti-logic interface. You got to know about. So I'm telling it to you. You heard it here first. Okay. So here we can pick their color, but what we really want is we want to make their color depend on their sex, right? We want to kind of rule, right? It says, so we can't just pick any old color. You know, we could, and we'll just make all of them that color. We want a color that depends. It's conditional on their sex. So how do we do it? Look over here. See that? You can choose, do I want a dynamic value? And the answer is yeah, I want a dynamic value. Thank you very much. I want a dynamic value. Okay. Okay. I'm going to have a dynamic value. What is this value going to be? Well, I'm going to say if they are female, make one color, otherwise another color. Okay, here we go. So I'm going to say if the sex is female, and the way I do this in Java is I do double equals, okay? Double equals. And I say if it's female, if the sex is female, I'm going to say question mark, okay, use, and I'm going to say yellow, otherwise gray, okay? I always forget whether gray is E or A. I think it's E. But sorry, is it both? Okay. Gray cannot, so maybe it's an A. I used to be more confident, and then I thought of Grey Poupon, and I got really confused. I don't know if it's a family name or a color name. Okay, here it is. So I'm going to copy this up. This is a little bit of syntax for you, but basically what I'm saying is, hey, is this true? Is their sex female? This double equals means we're testing if it is equal. If it had just been a single equal, you would have said like, make their sex equal, and that's not what we want. Make their sex female. No. We want to test, is it female? If so, that's the question mark. If so, make it yellow, otherwise make it gray. And it has to be spelled with A for reasons obscure entomological. Okay. And I'm going to build this model. And I built early and I built often, and it is a happy camper. Okay? Yes, Michael. Yes. Yeah. By demand, I recognize that needs to be done. I'm trying to figure out which exact day we have it, but yeah, I will have a Java session, and it's even possible I'll have more than one depending on the need. Okay. So that now, the truth is, I could have been more pedantic about it, or more specific. I could have said sex.female, female as in sex, but I'm not going to do it right now, and I'll just get away with it right now. Okay, so let's run this thing. Let's run it. Can we run it? Can we run it? Okay, who needs TA help? The TAs, their numbers have swelled. Call upon the TAs, so mighty in form, so great in number, to sort of draw on Kelly. So see if you can draw on them, exercise their skills, build their modeling repertoire, and help them realize their potential. So here we are. Who are the yellow here? Females, and the grays are the gray over there. Okay, great. So all we did there is we manifested people's appearance. Now, you'll notice, ladies and gentlemen, I've already gone through all four of these without realizing it, perhaps, right? We introduced agent parameters. Yeah. What agent parameters do we have? Anyone want to say? What parameters do we have in this model at an agent level? So age and sex we have, right? And then populations. Where do we have a population in this model? The population in Maine. Don't be distracted by the fact that there's a population here. Don't be distracted by the fact that there always needs to be one population. No. You could have multiple populations. You could have multiple cities, each have its own population and its own age distribution. You could have a population of people and a population of service dogs. You could have a population of mule deer, of people, and of ticks, or what have you. Heterogeneity. We introduced heterogeneity in sex and age. And we have declarative visualization. We made age their location based on their age, and we made their color based on their sex. But we don't have yet statistics, and I'd like to do something for that if I could. So we have some characteristics here that we're building on, but we've covered these basic elements. So what we've seen is this is largely declarative. I mean, we can insert some rules and so on that say what someone's color and their appearance, what someone's age is, and we can make their location based on the age, but it's quite declarative. Doesn't require a lot of coding. Let's continue on that thread. Let's add in a statistic. We're going to add in a statistic that's going to compute the mean population age. Okay, and maybe we'll do it for men and for women. Okay, separately. Okay, So we'll have an overall, and then we'll have one for each of the sexes. This time. Are we ready for this? Who needs a little bit more time? Anyone? Okay. So once more into the brief, ladies and gentlemen. Does anyone want me to save this model and post it? I'd like to do that periodically. And the only question is when I do that. I will definitely do that shortly. Would you like it posted? Awesome. Okay. So I'm going to call this Simple Gender Disparity version 1. By the way, best practice here. Version your models frequently. Create copies of the working model so that when you go on, you always have recourse to that last model that you created that was working. You have a latest working. Now, if you talk with many of the people here, they'll tell you that there's fancy systems to take that much, much further. Things like Git and Subversion, version control systems, which are starting to appear even in the data science world. And those are great, but the basic rule is create versions of your models. And if you have to do it by just saving them periodically with different names, maybe version 1, version 2, version 3, that gets you very far. Always have a fallback model you can fall back on that's working. It's a point of reference, okay? Take my word for it. Take it, ladies and gentlemen, I'm an old man. Okay, okay. So I'm gonna go post that, and I will do so in a moment. So give me just a minute, Maya, and I will get it over to there. Okay, so go. Great. And we want to put it so for those who are following along, if while I'm doing this, you want to spread things out, you might want to see if you can have those agents be spread out in their Y location more, and think about how that's done. Okay, no, it's not one of these. It is okay. So pardon me, there we go. And great, there we go. And great, there we go. And I'll put it in the participant resources and models built in class. Great. So I'm uploading it. Go. And Humble. Okay, so I want to do it in under my, I want to do it in models. There's my models. There it is, version 1. Okay, I'm sticking it there. It's in example model built in class. Okay, model built in class. Awesome. Great. Okay, so ladies and gentlemen, so thank you for asking me to do that. It's a good resource. So we're going to compute some statistics. How are we going to do that? Well, statistics are computed over a population. Now you can compute statistics in many ways. And in general, ladies and gentlemen, this is one of the differences, mark my words, between agent-based modeling and a tool like system dynamics. And system dynamics, we're operating, I had noted earlier, with a much more, we operate with kind of facility and finesse with a smaller modeling vocabulary. We're very creative about how we use a small number of elements to greatest effect, kind of a minimalist design set. With agent-based modeling, often we have many choices how to implement things. And part of what I'm doing in this boot camp is to give you some really elegant ways to accomplish things you could accomplish another way in kind of a ham-fisted way or kind of an awkward way. So you'll find, not just in my instruction here, but in the many example models, things are done in a thoughtful way to allow it to be done with a minimal fuss and muss and mechanism. Okay, that's a lot of what I try to impart here. So statistics are one of these things that can be computed in many ways. You could write brute force code to export things and then run them in R. You can go and write some code to compute them, but there's an elegant way to compute many of them. And it's elegant and it's transparent and it's visible to stakeholders, very good to support participatory modeling. And that's located in the population. So a population has the ability to compute statistics about the agents in it. So if I go to the population lives in Maine, and I go to statistics, there we go. You notice it says no items defined yet in under statistics, this little statistics area. I'd like you to do a plus there, okay? And we're going to say the name. Okay, now. Java, ladies and gentlemen, when you're working in logic, Java may become your friend. It may become at once your friend and maybe a love-hate relationship. So Java does not allow spaces in names. Okay, it's not going to be happy if you put a space in a name. If you put, bar zap, it'll be unhappy. It'll show you this little X, and it'll say it's not a valid Java identifier, which is its base way of saying like, I don't know what you're telling me the name is, buddy. Like go figure. So I'm going to say mean age. Notice I either use this convention of what's called camel case, or I would write mean underbar age. And opinions differ. I tend towards the camel case camp, but other people prefer this one. This one is more prominent in certain worlds like C programming. I prefer this, but you can take your pick. This is an underbar. Okay, that's an underbar, not a dash. It's not a minus sign. It's an underbar. So I'm going to call it mean age with a capital A. Okay. You can take your pick how to do it. Great. Mean age, and I'd like it to be an average, ladies and gentlemen, over what? Remember, I'm telling you something that's declarative statistics here. So we're going to say it's a mean age over, so it's an average over their, anyone want to guess? Their age. We're going to say it's an average over age. Now, that's the rub. How we're going to say it's their age. It's an average over their. Who is they? It's the person in the population. So it's going to go one by one through each of those people in the population, and it's going to compute this age. Okay. And so we're going to have to say, like, for each person in the population, take its age. And the way you do it, notice there's this little like light bulb turning on. It's like it's giving you a hint. Use item for the agent of the population. In other words, it's telling you, hey, when you write this, you use the term item to mean the person at issue here. So I'm going to say item. I know that sounds, rather crude pronoun to be using, but I'm going to say item dot age. Okay, item dot age. There we go. We're going to take an average over the age, and it's no condition. We're not going to have any conditions for this one. No siree. Okay. So it's a mean age. That's all there is. Build. Let's go build. Oh, I should have said, what's this dot? What's this dot thing? So what is this? Oh, what's this dot thing? Yeah, you're starting to see the dot a lot. Dot means items age. It's almost like an apostrophe. It's like the age of the item. Okay, it's like items age. It's the age of item. Okay, that's what that means. The dot. Sometimes you see a couple of these in a row. This, it's like the collar of the dog of the instructor, or something like that. So it'll be like instructor dot dog dot collar. Okay. I don't have a dog. Okay, so that's the age of this thing named item. Okay. Okay, so let's try this. There it is. By the way, it gave it this little hint. Pay attention to those hints. There was actually a hint just like that for self. It said like, use self. There's self. Okay, so let's try this. Ready? Here we go. Run. By the way, I built it first and it was happy. Okay, so I don't see anything, but if you go up and click on the population, notice it says now mean age is 43.715, no less. Do you see that? Okay, that's a mean age across the whole population. You just computed a statistic. Go to, hey, go compute this average. Not bad, eh? Now let's do something a little bit fancier, if we may. So I'm going to go again, and I'm going to add another statistic. Ladies and gentlemen, where do the statistics live? Where did that statistic live? Where did I define it? Does anyone remember? Population in D. And so we're going to go back and define another one, but it's going to be specific to men, and then another one specific to women. Define the mean age of them. Okay. Is that okay? Okay, let's try this. Okay. Who needs help, or does anyone else want to ask a question so far? Okay, thank you, Wade. So the chat window is okay. What's the difference in item.it? Yeah, okay, great question. Okay, so this is an AnyLogic thing, and I will seek to note it again. So the basic gist is that so when you're putting a bit of instructional code here, this is code. Those in the room may be surprised to know your Java program. These are actually bits of Java code. Okay. And when you're writing them, AnyLogic commonly gives you hints of it gives you contextual information available for you to write it. So when you're saying what you want to take the average, it gives you a name for the agents over which you want to take the average, the agents in the population. And it gives them the name of item. It's not particularly deep, it's not particularly significant, but it names them item. And you could see that by looking at this little thing. It could have called it member, or it could have called it, agent or whatever. It could have called it many things. It called it item. Okay. And it's when we are writing statistics, we use this thing. It provides us. That's what it's called. And so we have to accord with it to refer to the person over which we're taking this average. We refer to it as item. Okay. Now self is a different context. This is when the agent is being created, Sungju. So it's when the agent is being created in the first place, okay? And the agent doesn't exist yet, it's being created. And we're saying, hey, give it for, refer to that agent being created, their characteristics with self. So it's the person being created's age. There's no item here because we're not computing a statistic over a population. It's just self is the kind of the name of the agent being created. And that's not, I recognize that's not awfully helpful, but that's like in this context of initial location, you're going to use self because that's what it calls the agent being created. And it gives you that hint here at the end. It says self. And this one, it says, hey, use item to be the agent of the population. So I'm afraid it's not terribly deep, but those are the names that AnyLogic in particular happens to use for those contextual pieces of information. I hope that's helpful. Other questions? Okay, can we use person and, oh, sorry, yeah. Sort of, and let me state what I mean by that. Okay? So if you want to learn R, you need to learn the R language, to use R effectively. If you want to do data analysis in Python, you need to learn some Python to do it. You might not need everything in Python. You won't be creating user interfaces. You won't be, building systems that are, I'm going to use what's jargon, multi-tier system for communication from backend to front end. There's a lot of things like in Python that a Python data analyst wouldn't end up using because they're not germane to their job. It's a subset. I would say any logic's use of Java is even more constrained than that. It's a small subset of Java that you will use frequently. And I have seen people who see this and they say, oh, I better go take a Java course. And the fact is, if you take a course in Java programming, 80 to 90% of what you learn will not be applicable because it will just be much more than you need. What you need is a swath of Java that's fairly defined for most things. Now, I will say that if you really want to make an any logic model that's very sophisticated, so it's doing age-based modeling in a very rich sort of way. It's computing some things. You will be using that subset of Java quite a lot, but generally speaking, it's quite a small subset of Java. I would say I would not recommend someone go up and take a Java course for this. It's like overkill. At least that's my view. I'm interested in the TA's view.
I feel like going on something such as secondary schools or Khan Academy, stuff in Java would give you the tools you need for the most part.
Yeah. Wade is responsible for some of the most sophisticated models around. And Wade, I'm interested in your sage observation.
Yeah, an intro Java course is probably helpful, but like general purpose Java programs pull in lots of parts of Java that you may never use if you're focusing on debug. It could be a waste of your time if you don't want to branch out into other applications.
Yeah. No. So those are good comments, and I appreciate both of those. I think if people are interested, if you were to take a TA or myself and corral us for half an hour, we could probably sketch out like these are sets of things you'd want to know in Java. But there is a difference also between building smaller models, building larger empirically grounded, really performance models, and on the other side, consuming and modifying models built by others, but not doing the building from the ground up by one. Those are three quite different things in terms of the level of sophistication of Java. If you want to build large, very, very rich models, I would say, yeah, it probably is worth investing a little bit more, recognizing that it's a good part of it that you won't need. It depends on, I think, aspirations, and I think it's worth having a discussion about that. I will say that one thing that if you compare any logic in Java to some other platforms, for example, Repast is in Java as well. And Repast is much more heavy on software development. you basically need to become like a software developer. And much more so than anyone. Net logo has its own funky language, to which I've objected since 1990, probably before many of you were born. You know, I think it's a horrible language. And I think they're doing a disservice by using that language, and it's very specialized, so you're not gonna be able to be forced. One thing that AnyLogic does have is, you know, Java resources are just like everywhere, because it's an incredibly popular language, and so it's pretty easy to pick up a subset like Khan Academy and so on. Net logo, it's very particular to that platform, so it's a little bit kind of more weird to pick it up. And you know, you're unlikely to find someone to help you with that unless you're, you know, dealing other with net logo program. So I'd say that's another trade-off here. I don't know if that's helpful. Yeah. Yeah, it's a matter. It's a good question. So all of these. So I'm going to say something which is deep, but it may be. It risks being mystifying. So all of these platforms, you can do anything you want, basically in any of the platforms, because they're what are called computational universal. Anything you do in R, I can do in AnyLogic. Anything I do in AnyLogic, you can do in R at some level. The question is it going to be painful? You know, how painful is it? And part of the issue is that there's enormous, there are broad areas where things are very easy to do in one platform and not the other. And it's very natural in one platform and painful and twisted and convoluted in another. And really, it's not a matter of can you do it for most of these platforms. It's how bad is it, okay? And I would tell you, like, to do this in R, I would say, yeah, it could be done so far. It wouldn't be too bad. If you took it one of Wade's files in R, I'd say it would be like a kamikaze mission. It'll be like the death stretch of the Burma March. Like, I wouldn't want to get anywhere near that because it would just be so horribly complex and so twisted that I wouldn't, it would just make me feel ill to kind of contemplate it. And I would say, you know, this is really what you're dealing with. It's a matter of how natural is the tool for the job. It's kind of like, you know, could I put in a new roof, like put in nails all throughout my roof, and put in new shingles with a saw alone? Yeah, I could do it, but it's kind of wacko, you know. Or could I do it with a chisel? Yeah, I guess I could, but it would be not the right tool for the job. So in my mind, this is a matter of what's the right tool for the job. And for agent-based modeling, there are some platforms, there are many platforms I will be discussing later in the class. And they span from R to Julia to NetLogo to ModGen to AnyLogic, Recast, and custom building code. And I think I can talk about the trade-offs of each of them, but I would say there's no free lunch in the sense that there's going to be some areas which are going to be painful in one platform, but easy in any one of those. And I can take any one of those and probably say, you know, pick that platform. There are some things that are quite easy and some things that are going to be horrendous. And you just got to kind of know for the types of things you want to aspire to, which platforms would be acceptable for their for the trade-offs. I would say that's the main thing in my mind. I say that's having used seriously, you know, a good like very, very seriously 4 to 6 years. Okay. Any other questions, comments? Can we use person dot, unfortunately, no. Can't use person dot. These are sort of things that are used in these contexts, and any logic will tell you. It's basically contextual. Okay, any other questions? These are wonderful questions. Okay. Mindful of the time. I think we'll, oh, yeah. So we're going to finish the thought, right? We're going to compute these statistics in with males and females. By the way, this would be really easy to do in R. You know, like this part of it, right? Computing statistics over things. I do that in R any day. That's wonderful. The fact that it can be done in any logic is nice. You can plot it out in live graphs while the model's running. You can, you know, have outputs that will take advantage of it to show quite sophisticated analytics while the model's in operation. But a lot of things like this, if it can be done after the model runs, I'd say export them to an R would be my preference. Okay, so I'll say mean age males, something like that, or mean age for males. I kind of like that. And I'm going to say average. Okay, so what do you think this is going to be a mean over? What do you think? Anyone? Yeah, item.age, exactly right. So what's the difference? Condition. Yeah, we want this one limited to whom? Only males. So we say item. You notice it's giving us a hint again. It's going to say, hey, use the item. Dot, and what? What are we going to test? If they're, yeah, and how are we going to test if they're male? If they're what is what? Yeah, and is it lowercase or uppercase? Lowercase, because it's the particular sex of this person. It's not asking if, like, sex as a category is male. It's asking, oh, and wait, no, what's wrong with that? Double equals. I'll get it up on the big screen there, Mike. Here. There we go. Boom. That's what we want. You're just saying, hey, is it equal to male? That's what. That's it. If we're equal to what would happen? What horrible thing would happen? Yeah, we just assign it. And actually, it will complain. Any logic will complain. It will say, like, basically, I don't understand what you're doing. Because this won't be a test. It'll be like a you know, why are you giving me a sex there? I want to test whether or not it's true. Okay, great. And so how would I define this for females now? Anyone? What would I do for females? Yeah, exactly. You know, that's it. That's it. You got it. You got the pattern. So this is average. And by the way, you notice it's telling me like these things in this problems window. Problems window is your friend. You may think it's your enemy, but it's your friend. It basically tells you, hey, I really don't understand what you're trying to do here. Help me. Help me. Okay, and there we go. And you notice sometimes it's a little bit, it doesn't catch up, but I did build, and it's a happy camper. See that? Build completed successfully. It's happy, it's smiling, and now we're going to run it. Isn't it smiling, Larissa? Yeah, it's smiling, and it's Silicon Way. Okay, and we're going to go down and, oh no, where do we look for the statistics here? Who can tell me? Yeah, yeah, actually, it's in the population. Boom. Yeah, here we go. So the mean age for females is that, the mean age overall is this, the mean age for males is that. Okay. Great. Great. Okay, now, I was going to put in income, but I want to get to state first. Really want to get to state. Let's take a break. Let's do state first. Is that okay? Okay, so we're going to take a 15-minute break, and I've got to do some administrative work of rather unpleasant type quickly, having nothing to do with the boot camp. So I'm going to scroll down here, and we'll reconvene. We'll reconvene, ladies and gentlemen, in 15 minutes here. Okay, and we'll get into state charts, and we'll be adding behavior because right now these agents are static. They're just sitting there like lumps on a log doing nothing, right? And so we're gonna add in some state charts. And we're gonna give them a life of their own, a vitality worthy of their name, a person. Okay, thank you, folks. We'll see you in 15 minutes here. And I'm going to stop said recording. Okay. Okay, see you folks in 15 minutes here.